Hi all, welcome to the first part of the video lecture on relational algebra. See, what's relational algebra? So first of all, it is a formal language of relational data models. Relational data model is what we discussed so far, and you know how this information database will be represented in a model like a relational data model, which is based on the set theory concept relations, and we gone through its formal definition, constraints, and many other properties. Okay, so right now you know what is relational model, and before that we discussed that ER model, which is a conceptual model, and when it comes to relational model, it is the implementational model, right? And we also seen that formal way of mapping a given ER model to relational model. So now it's time for us to discuss the formal languages that come along with the relational model. Okay, so when this EF code proposed this relational model, along with this model he proposed some formal languages also. So at the same time we have the practical language also, that is SQL. Following this relational algebra we will be focusing this SQL, but our first agenda is to understand this relational algebra. So remember, it's a formal language, so it's something like a algorithm, you can think like this. So before writing something you typically write algorithm, then you write the formal code, right, using some programming language. So like that, if even though in exam if they are asking you to write the SQL query, it is better to write this relational algebraic expression also. So from that it is easy for you to convert to SQL. Okay, so anyway, so there are two formal languages which are associated with the relational model, that is relational algebra and relational calculus. Even though both of them are there, as per your syllabus you have to study on relational algebra. Calculus I will not be discussing as it is not there in the syllabus, but from textbook those who are interested can follow it. Because calculus is actually more popular as well as advanced, but anyways in your syllabus, as we have only relational algebra, we will be seeing this in detail. Okay, then we will discuss this SQL, and you can see that it's a practical language for relational model. So it's a standard. Okay, historically the relational algebra and calculus were developed before this SQL, and SQL is primarily based on concepts from relational calculus. That is what I said you already. It's mainly purely SQL is based on relational calculus and has been extended to incorporate some concept from relational algebra also. So those who are interested, it is better to see how this relational calculus is working and how relational calculus expressions can be written for a given query. Okay, but anyway, we will be focusing our syllabus, I mean 2019 Kincative syllabus, where this topic is not there, so we will focus only on relational algebra here. Okay, see, relational algebra, the basic set of operations for the formal relational model, right? So relational model, you know formally what it is, and the basic set of operations that we can apply over this relational model is what we can call as relational algebra. So it's an algebra, right? So having set of operation, and typically we write something called as a relational algebraic expression. I mean we will see how it can be written using relational algebraic operations. Okay, relational algebra operations thus produce a new relation. So this is something important. Whenever you apply any relational algebraic operation, say together, whenever whatever be the relational algebraic expression you are having, once it is being executed, the result is a new relation. So keep that in mind. So you know what is a relation? Basically it is a set of tuples, right? So within a set, elements are not supposed to repeat. So the concept of key, uniqueness, everything is by default implied there. Okay, so the result is a new relation in the sense it should follow all the properties of the relation that we discussed so far. Okay, but if you are looking at in SQL, given any query, after the execution the SQL is not going to give you a relation, in the sense the result may not be a set, it can be something like a multi-set, in the sense the elements may repeat. Okay, SQL is not doing any duplicate filtering by default. So but we have separate keyword like distinct and all, using which you can do this duplicate filtering. But relational model, I mean this particular relational algebra as a formal language to relational model will do this duplicate filtering, and it will always ensure that the result of this relational algebraic expression is going to give you a relation with the standard definition of relation. Okay, I mean tables. A sequence of relational algebra operations forms a relational algebraic expression that we will see. So throughout the concept we will be seeing how relational algebraic expressions can be written for a given query. whose result will also be a relation that represents the results of a database query. Now, why relational algebra? So, there are three reasons. First thing, it provides a formal foundation for relational model operations. As we already know, the relational algebra is formal language for relational model, right? So, it acts as a formal foundation for the relational model operations. Second thing, perhaps more important, it is used as a basis for implementing and optimizing queries in the query processing and optimization module that are integral parts of relational database management system. Anyways, this query optimization is an advanced topic we may not be covering as part of our UG course, but still you should know what it is. Like whenever user is giving some kind of query, typically you will write your query in SQL language and all. So on background, just like a DBMS or DDL compiler, something like that will be running on the background, where it will take the query from the user and it will try to see how efficient we can execute the query. So efficient in the sense we have to reduce the time needed for execution. So some kind of background processing will be happening over any given query, or we will try to the DDL compiler will try to optimize the query. So optimization of queries is a research area, and there are a lot of things there. So it's something beyond our UG course basically. So that optimization of queries itself you can study as its different course. Okay. Anyway, this relational algebra is going to act as a basis for this query optimization. So, so when you write something in relational algebra, from that point it is easy for us to move on to this query optimization. Okay. Now the third thing is its concepts are incorporated into SQL standard also. As you know, SQL its importance. So it is basically taking the concept from relational algebra, so that also makes this relational algebra popular. Okay, see 3 points. Yeah, relational algebraic operations. Relational algebra operations can be divided into two groups. Okay, one group includes a set of operations from the mathematical set theory. These are applicable because each relation is defined as a set of tuples. You know, relation is a set of tuples, right? So what are all the operations that we studied in set theory? You can apply here also, right? Like a union operation, right? Union, the intersection operation, the set difference operation, the Cartesian product or the cross product operation, everything are applicable here also. But now we are going to do union of two relations, in the sense the tuples are getting going through this operation. Okay, similarly intersection of will give you the common tuples, set difference and Cartesian product, you know what it is, and that we will apply our set of tuples here. Okay, now the other group, the second group, consists of operations which are developed specifically for the relational databases, and that includes, there is something called as a select operation. We will see, we will be starting with these special operations, select and project, and there is another one called a project operation. Okay, so they are basically unary operations, and there is a binary operation that is newly here, that is join. Okay, so this all of them are equally important. Some common database requests cannot be performed with the original relational algebraic operation, so additional operations were created to express these requests. So additional operations, in the sense there are something called as the aggregate functions, which are operations that can summarize the data. We will see count, sum, like that. Aggregate functions are there, as well as join itself, union itself. We have variations like outer join, outer union, like that. Okay, so like that many things are there, but anyways, again we will stick on with the syllabus where we are supposed to know the basic operations only, like especially select, project, join, Cartesian product, like that. Some of the operations are highlighted in your syllabus, that we will see in detail. And this aggregate function and all, anyway it is there given as part of the SQL. So when we discuss SQL, we will see aggregate function. The same concept here, notation varies, that's all. And again, what are all the things I am covering, you can have your own additional reading to understand more. Okay, so my classes are mostly based on the syllabus. Fine. So let's start with the unary operation, relational operation, that is select. The select operation is used to choose the subset of tuples from a relation that satisfies a given selection condition. So typically, so let me directly go to the example, like how we can write it. So it is something like this: sigma. See, sigma stands for the select. Okay, so this is the notation for selection. Okay, so I'm trying to select something. From where you want to select? I want to select some information from the employee table. Okay, so that you have to mention as an argument for the sigma. Then you have to write the selection condition. So what is the selection condition? Look at the employee table. Take all tuples or rows having the department number field a value 4. And hope you remember we are taking that employee database that we are taking from the beginning onwards. I mean, sorry, the company database where this employee table, we already seen how it is mapped, what are all its attribute, everything like first name, middle, initial, last name, address, age, like that many information. And also for that foreign key referencing concept to implement that, we have that department number also we added. Okay, so where you will get an information about the department where this particular employee is working. Now here we are interested only on employee details who are working in department number 4. So simply you can select them from the whole relation, say employee, using this kind of a select relational algebraic expression. Now similarly another one is like here you want to know the details of all employees having salary greater than 30,000, so that you can return like this. Fine. So like that you can write anything, but basically what it is doing is it is doing a horizontal partition. So this is important. So basically, you know, when you are writing something like this, it will take each tuple or row of the relational algebra. Okay, each tuple, one tuple, you know, it contains value corresponding to all the attributes. Fine. And then it will directly go to the department number field alone, and it will check whether it is equal to 4. If it is equal to 4, condition is true, otherwise false. Accordingly, the entire database you will divide horizontally into 2 partition. And you know what is partition in set, right? There is no common element. Its union will give you the whole thing. So that is partition, right? It's the concept you studied in set theory. So you are going to partition the whole database, which is in the form of a relation or table, into 2. And one side it contains all the tuples or rows that satisfies this condition, I mean the selection condition. So or all tuples having department number is equal to 4, and the other side we have all tuples which violates the condition, right? So the relation or the table is partitioned, so that is the correct word, into 2 sets of tuples. Those tuples that satisfy the condition and are selected, and those tuples that are not satisfied by the that do not satisfy the condition and are filtered out. So the final result of the query is only those tuples that satisfies the condition, other things we will filter out, right? So that is how you can visualize this selection operation. So we can consider select operation to be a filter. So it's like a filter which will apply this selection condition that keeps only those tuples that satisfy a qualifying condition. Alternatively, we can consider select operation to restrict the tuples. So either it will filter or it is going to restrict those who are violating the condition, right? Restrict in the sense the tuples in a relation that only that satisfy the condition will be coming out finally. So example you can see like this. Okay, now I just want to highlight something that we are going to study next, that is a project operation. So similar to select, we have another operation called project. Okay, project. So we are going to see it. So typically we denote it by pi. Okay, so select is like a sigma in that way. So now why I discussed it here, because you know when you are writing like this, you are going to get the complete details of the employees having department number is equal to 4. But suppose you are interested only on, say, the first name of the employee who are working in department number 4. You don't want to know full details, you just want to know their name, or you want to just know their first name and salary. So what you can do is you can write further like a pi or project first name comma salary from this result, something like this you can write. Okay, so now why you are writing like this? So this is now, so we are going to discuss this project operation only, but before that I given you feel like how this project is going to work. So selection is basically going to give you a horizontal partition, like all those tuples satisfying the condition and violating the condition, like that you will divide. Where project operation is going to do a vertical partition, right? In the sense the given, I mean again you keep in mind like whatever be the operation that we apply in relational model, I mean using relational algebra, whether it is select, project, or any set theoretic operation like a Cartesian product, union, intersection, whatever it is, the result is always a relation. So here also you can see that this result is going to be a relation, but anyway as key is involved, it will satisfy it, but even though it is not there, it will keep that in mind. So we are having a relation in the sense elements are not going to repeat and all columns are here, right? So out of all columns, I mean from the employee table, say first name, last name, middle initial, salary, age, I think many things are there, right? So look at all those attributes, but we are interested only on the columns first name and salary. So from the result that contains all columns, it is going to filter for the first name and salary, and it will project only the information, that is first name and salary of employees having department number 4. Okay, so like that you can do. So now it is a vertical partition, right? So the particular relation you are vertically classifying into 2, those which are there in the attribute list given by the project condition. So here the attribute list is containing first name and salary, and which are not there in the attribute list. Okay, like that you will be vertically partitioning. Now let me tell you one more thing. This project operation is also going to give the result as a relation. Okay, so that is very important. The result of the project operation is going to be A. So the final result should be a relation in the sense no repetition, right? So we need a set, okay, or set of tuples, something like that, okay. But you know, the finally you are going to output this first name and salary only, and 2 employees may have same name and same salary. It can happen because this employee name is not a unique attribute, salary is also not a unique attribute, right? So in that case, what this project operation will do is it will do all the duplicate filtering. So all duplicates are filtered out by the project operation. So this is very important to maintain this concept, because whatever be the operation that we are applying, whether select or project or any set theoretic operation, whatever it is, the result should be relation. So that is what is the main concept that you have to remember from relational algebra. Something like that is not there in the practical language like SQL, so keep that in mind. So to maintain that, if the result, so here of course it is not a key, super key, right? It's first name and salary, so definitely it will repeat, and if it is repeating, the project operation will automatically eliminate all duplicates and it will be giving the result in that way. So okay, but in SQL it is different. Okay, so that about it, what I want to highlight. Now this is a general form of select operation. Sigma, a selection condition, and the name of the table. Fine. So sigma is used to denote the select operator, and the selection condition is a Boolean algebraic, Boolean expression or condition specified on the attributes of the given relation, right? So notice that R is generally a relational algebraic expression whose result is a relation. So here it can be a single relation name, just like here, like employee, or this can be a result of another select query or something. Okay, so always this is a relation. It can be a actual relation or the base relation from the database schema, or it can be the result of applying some other relational algebraic expression. Okay, so the simplest is the particular relation itself, otherwise it can be a result of something. Anyway, it is a relation. So the relation resulting from select operation has the same attributes as that of R. Okay, because we are just printing all attributes of R, right? The attributes are not filtered out. To filter out the attributes or to project something vertically, we need a projection operation, and the project operation, that is what we are going to see. Okay, now what about the selection condition? Typically it is of the form some attribute to name, right? So here you can see name of an attribute, then a comparison operator, then a constant value. Sometimes it can be a constant value, sometimes you may be comparing one attribute value against another attribute value. So here you can write another attribute value also. Okay, like if you are looking at 2 different table, department number from employee table and DNUM from department table, like that 2 attributes also you can compare, or a attribute you can compare with a constant value. In between some comparison operator will come. So the format is like some attribute name, comparison operator, and a constant value, or attribute name, comparison operator, and another attribute name. Okay, so this attribute name is a name of some of the attribute from the relation R. Comparison operator can be anything, like it can be equal to. Okay, fine. So from this set it can be anything less than equal to. Okay, constant value is a constant value from the attribute domain. So you are not supposed to violate the domain, otherwise it will be an error. Okay, Yeah, that's all. The clauses can be connected by further when it comes to the condition, multiple clauses can be connected using the and or not operations like this. For just see this example, what we need is we want to select the tuples of all employees who either work in department number 4 and make over $25,000 per year. Okay, so salary greater than 25,000 and department number 4. And okay, so this is one condition, or another condition is like who are working in department number 5 and make over this much salary. So you can simply write the query like this: DNO, the attribute name, is equal to 4, and so this like this you can use salary greater than 25,000, or department number equal to 5 and salary greater than 30,000. So what is the requirement? Accordingly write the selection condition. For that you can use this and or not and all. Okay, fine. So this kind of comparison operators typically we apply to attributes whose domains are some ordered value, because when it comes to greater than, less than and all, some kind of ordering should be there. So typically numbers and date, they are ordered, right? In the sense you can compare two numbers or dates, right? Sometimes you can compare the strings also if the characters are considered to be ordered, like if you are following that alphabetic ordering, with that you can compare the strings also. But suppose your attribute is something like a say color, which is an enumerated set, like which can have values like red, blue, green. If we have an enumerated list like this, can I use less than or equal to something? How can I compare two colors? Because here color, in the sense we are not going to use that alphabetic ordering. Okay, so that is something meaningless here. So here we can either use that equality or not equal to. Okay, so that only applies. And basically this select is a unary operator, as I already told you, and we are going to apply this on each and every tuple in the relation individually. Okay, hence selection condition cannot involve more than one tuple. So tuple by tuple processing is happening, and at any time you can see that when you apply this select operator with a condition C on this relation R, the result of this selection operation is always having a cardinality, which is a number of tuples returned by it, less than or equal to the cardinality of the original relation. That you write because you are getting a subsets of relations. That's why. Worst case, it may be the same relation itself, and that time that equality happens. And the fraction of the tuples which are selected by the selection condition is referred to as selectivity. For example, the original table is containing some 1000 tuples. The selection condition say department number is equal to 4 is selecting only 100 employees as a result. So the selectivity is something like 100 by 1000. Okay, so that fraction out of 100, this selection condition is selecting some, out of 1000 selection condition is selecting some 100 tuples, in the sense the selectivity of this particular condition is like that. Okay, so that is how you can represent. Now another important concept is this select operation is commutative. Okay, commutative, and you know what is commutative property? The you can apply like in any order, like here we have two conditions, right? So here I am applying condition 2 first, then condition 1. Okay, whatever it is, then here what I am doing is I am applying condition 1 first, then condition 2. So you change the order, the value remains same. If you want, you can relate it with some example that we saw already. Like I want to know the details of the employee who are working in department number 4 and who have a salary greater than 25,000. So there are two conditions. One condition is who are working in okay, so the condition number 1 is department number is equal to 4. Okay, so from the employee table you are selecting all employees who are working in department number 4. Then from this result, what you can do is you can select those tuples with the salary greater than 30,000. Okay, whatever it is. So you can do like this. Now you know you can do the same thing, like you can first apply something like a salary greater than 30,000. You take all the value from the employee table. Okay, I am writing like this. You use a full name if you want. Then from the result you can take this salary condition we already applied. So from the result you can take those tuples with the department number is equal to 4, something like this. So whatever be, both are of same, right? So these two are equivalent. Now it is something written in a different way, like selection department number is equal to 4, and we typically written it like and. Okay, so basically we are applying this and operation, and another one is salary greater than 30,000. we are applying both of this condition on the employee table, that you can apply one after another or together or in any order, right? So when you have this condition 1, condition 2, etc., so basically we are doing this AND operation among all these, okay? And this, the AND operation is commutative, so that these things are also commutative. You can apply them in any order, okay? Yeah, now just how this relational algebraic expression can be related with the SQL. SQL we will discuss after this only. But anyway, I hope that most of you have an idea about SQL. Okay, in small classes itself, most of you, if you are from computer science background or something, like 12th, everywhere this SQL people are studying right now, I think so. Okay, or maybe as part of some project and all, you might go on through it. Anyways, if you don't know, don't worry. So it's a very simple concept only. So it is having a syntax, okay, just like you are studying your C program or something. Here it is having a syntax that you have to remember, and accordingly you have to write the queries. That's all. So the syntax over here, what you are doing is you are selecting the same thing, like department number 4 and salary greater than 25,000, details of employee from the employee table. So when it comes to SQL, you have a clause. We typically call it as a select clause. Okay, so we written like that. It's a keyword actually. Select. The star means everything, because here we are not projecting. Okay, so instead if you write like a project first name from this, then instead of this star here first name will come. Okay, where I mean like I just want to select only first name. Here I want to select everything, that is why this star is coming. Anyway, I am removing this. Okay, project we are going to study only. So just for a comparison I taken it, fine. From where you want to select? You want to select it from the employee table. Okay, employee table. Okay, so that is from clause, and then you have to mention the condition. For mentioning the condition, we have the where clause. Okay, where. So this bold, not only bold, these things like select from where. These are all the keywords that we are using in SQL. This and also other things. This employee is a name of the table that will vary. Right. Let me write something like this. This can change. Similarly, this name of an attribute. These things will change, but the keywords are not going to change. Fine. And we have the condition department number equal to 4 and salary greater than, so with a semicolon at the end we will write the SQL query. Fine. Now it's time for us to discuss project operation. I already told you what is project. Selection is going to give you a horizontal partition of the table, subset of relations satisfying a given condition. We are just picking them or selecting them from the table, from the original relation. Now out of them you are going to project only the fields that you are interested, right? So just like this you mentioned, say pi, I just want to know the last name, first name and salary from the employee table. I don't want to know the remaining fields. In the employee table there are many fields. Out of them I am just interested on these things only. So it is like a vertical partition. It is dividing the table into two. Those columns satisfying the condition, or which are there in the, it's not a condition, it's an attribute list, right? So those columns which are there in the attribute list and those which are not there in the attribute list, that will be discarded, right? So project operation is basically select certain columns, where select is selecting rows or tuples, right? Here columns are projected. Fine, that's all. Now this is a general format, like pi attribute list at the name of the table. So it's a symbol for this attribute list, can be any subset of attributes from the relation. Okay, again the result is always a table, keep that in mind. So attribute list, so the degree is equal to the number of attributes in the attribute list. Degree, in relational algebra, for a relation, what is degree? The number of attributes of the relation. Okay, now in case of selection operation, the result after applying selection operation is having a degree that is same as the degree of the original table, because we are not filtering the columns, right? So both the original table and after applying the selection condition, we are going to get the same set of columns. Okay, so the degree is same, but here the degree original table, for example employee, what is the degree? How many attributes are there in employee table? First name, last name, middle name, salary, address, many things are there. So that you count them. So that is a degree of the original table. But here this attribute list is listing only 3 attributes. So the result will have a degree which is 3. Okay. So the degree of the result of project operation is nothing but the number of attributes in the attribute list. Got it, right? Now there is something called as duplicate elimination, that also I told you already, because the result I want to be a relation. To make it happen, the project operation removes any duplicate tuples, so that the result of operation is always distinct tuples, in the sense it's a valid relation. Okay, right, yeah. Now by default the attribute list contains a super key. Super key, it should possess that uniqueness constraint, right? Super key, set of attributes having that uniqueness constraint. No two tuples are having the same set of attribute repeated. So if your attribute list contains a super key, in the sense one of the attribute in the attribute list is a key, you don't have to worry, definitely the result is not going to contain any duplicates. Okay, but if the attribute list, for example here the attribute list is containing first name, last name, salary, and it is not a super key, because there is no unique attribute. It's all together for two people, this whole thing may repeat, right? So it is not a super key. In this case the result may contain duplicate, and that is where you are applying duplicate elimination. So that is something automatically done by the project operation. Okay, so that is the default behavior. Now there is something like, what about the commutative property? Is it commutative? And you can see that this is not worthy, that the commutative property is not holding here. It does not hold a commutativity. Why it is so? Let's try to understand. So here we have two lists, say list 1 and list 2. From the given relation R, first I am applying this list 2. You assume that it is some subset of attribute. So let me take list 2, like say first name, last name, and the salary. Okay, then what you are doing is from this result, which is projecting first name, last name, and salary, you are applying another attribute list, and further from this result you are trying to project something. Now let me ask you, can I write say a address here? So now will it work? Because from the original table address is there, but for this particular pi, this result is being applied. Okay, in the sense this is going to, even though the original table is having this address field, this projection operation, this inner project operation is going to filter out that address and all other attribute, and it will give you a output which is a relation that contains only first name, last name, and salary. Now from that you are trying to take address, so this is meaningless. It is not going to work. It is going to give you an error. Okay, but at the same time, suppose I am giving something like a first name here, it will work. Or I can give something like a first name and a salary alone. Okay, this is going to work. So the criteria is, when you apply more than one attribute list like this in a concatenated way, something like this, in a cascaded way. So that is the correct terminology. So you have to ensure that the outer project operation should have an attribute list which is a subset of the attribute list of the inner project list. Okay, so first that inner attribute list project operation with the attribute lists first name, last name, and salary is going to be executed, and from that result, when you are projecting further, it should be a subset of it. Now the question is whether you want to do like this. If this is the case, first thing I want to tell you is, can I write it like a project list 2, then project list 1 of R? If can I write like this for the same example? Now this list 1, as you know, it is first name and salary. Okay, first name and salary. And what about list 2? It was first name, last name, and salary. First name, last name, and salary. Will it work? Again, it is meaningless because it is not a subset, right? First name, last name, salary is what I am having. From that I am trying to take a last name also. It is not going to work. Or I mean, this is what is commutative property, right? Commutative property is violated. If you change the order, that is meaningless. So keep that in mind. That is why it is violating commutative property. And one more thing is like instead of applying these two lists, it is always enough to apply this list 1 alone, that is first name and salary. Both are having the same meaning, right? Actually here from the original table I taken first name, last name, and salary, then I taken first name and salary from the result. Here I am directly taking it from the original table. Both are same. Okay, so when you write like this, it is better to write like this. So anyway, let me keep these attributes at the bottom so that you can refer. So some example you taken so that everything will be clear for you. As long as list 2 contains the attributes in list 1, in the sense it should be a superset of this one. Okay, then it is fine, right? otherwise it is going to give a wrong result. Anyway, you got it right. So it is noteworthy that commutative property does not hold here for the projective operation. Now again, let's see how this can be related with SQL query. From employee table, I just want to project sex and salary. Equivalently, in SQL you can write select. So in the previous case we written like a star in select, right? Select relational algebraic operation. Here it is select, mention the column name, that is sex and salary. Now you can see something called as distinct. So why distinct is written here? So this is very important because SQL is not going to do this duplicate filtering by its own. Okay, so if you want to do this duplicate filtering, you have to use a keyword called distinct. So if you use this keyword distinct, it will do this duplicate filtering, and the project operation by default it will do the duplicate filtering. So if you want this particular project operation to be equivalent to this distinct is important. If you are not writing this distinct, as this sex salary, that particular combination of attribute is not a super key, so in it may contain duplicates, so that may create issue, right? Yeah. We want both of them to be equivalent, that is why the distinct keyword is used. So notice that if we remove the keyword distinct from SQL query, then the duplicates will not be eliminated, so that it may not be same as the original project query. Yeah, that about it. So what we discussed here is the basic relational algebra, which is acting as a formal language for the relational data model. And there are many operations that form a relational algebraic expression, so by which you can express anything that you want to get from the database, some kind of retrieval query or something else you can express using a relational algebraic expression. And systematically we are going to see how this relational algebraic expression can be written for a given complex query. Okay, so we gone through two major operations, that is select and project. Select is going to give you a horizontal partition of the table. Project is giving you a vertical partition, and you can apply them together in a meaningful way. Yes. Thanks for watching.